Hi Brianna, it's Mr. Ng, and per your request, here is a video on specific heat calculations. These are the things that we've been working on this week, and I hope you'll do well on your upcoming quiz on it. Let's hop right into it. The first thing you gotta know is you gotta know this equation, right? C is equal to Q m delta T, and in class we've been saying Qmat because we just kind of pretend this delta, which really stands for change, we just pretend that it's an A, right? So C is equal to Q m delta T. C refers to heat. That means you're going to find this unit to be joules, sometimes cals, every now and then. Like on your quiz, it was in cals, but in the worksheet in front of you, it's going to be in joules. Q refers to specific heat, and this is the stuff that we've had all of our lessons on, right? We talked about how cheese has very high specific heat, which is why it kind of holds onto that heat for a long time and it burns your tongue, while the bread has a lower specific heat, so it doesn't kind of burn your tongue. Or water has high specific heat, it's 4.18 joules per grams, but then like something like copper or aluminum, like a conductive metal, it doesn't hold on to heat as much as water does, so it has very low specific heat. So Q refers to specific heat. It's a measurement for how much heat it takes to heat up a substance, or how likely a substance holds on to heat, right? Like just that chemical property. And the unit that you'll see here is joules per grams Celsius. Or sometimes you might see cals per grams Celsius. Okay, but those are both units for a specific heat. In the worksheet in front of you, you probably have joules. In the quiz that you'll see tomorrow or the next day, it'll be cals per gram Celsius. M is easy, it's just mass, right? It's going to be in grams. And then delta T refers to the change in temperature, right? And this is pretty easy, right? It's basically just the final temperature minus the initial temperature, or, oh, no or. And the unit here is going to be in Celsius. Shouldn't be an issue here, right? All we got to do is look for these units. So let's do one problem. We have a problem that says 100 grams of water is heated from 22 to 100 degrees Celsius to make a cup of tea. How much heat must be added? So this is what it wants. It wants how much heat is added, and the specific heat is 4.18 because it's freaking water. If it wants how much heat, that means it wants C. So that means we don't even need to rearrange the equation. We just have to kind of plug it in. So 100 grams of water is mass. 22 to 100, that's the change in temperature, and it went up 78 degrees Celsius, right? That's the change in temperature. And then 4.18 is obviously the specific heat, so we just want to know C. So C is equal to Q times M times delta T, Qmat. And we don't know what C is, but we do know that Q is 4.18 joules per gram Celsius times the mass of 100 grams. Grams will cancel, that's on the bottom. And then times 78 degrees Celsius. And look, Celsius is on the top, this one's on the bottom, so that cancels too. So all we got to do is punch it into the calculator. So it's 4.18 times 100 times 78. And I got C is equal to 32604. That's a huge number. But probably the easiest way for us to write it would be 32.6 kilojoules. How did I get kilojoules? Well, I just divided that by a 1,000. Divided by 1,000, right? So, boom. Seems pretty easy to me. Let's do one more, right? All we did was we identified what variables they were, we plugged it in, and we solved it with algebra. Kind of the same old thing we've been doing all year. All right, let's do one more. A block of aluminum weighs 280 grams. Obviously, this is going to be our mass, and is cooled from 104 to 64.2. So let's do that math real quick. 100.4 minus 64.2. I got 36.2 degrees Celsius is the delta T, right? With the release of 2,160 joules. That's going to be C. From this data, calculate the specific heat. So it wants Q. So that means we need to rearrange this equation just a little bit. So that shouldn't be too bad. So C is equal to Q m delta T. And we want to get Q by itself. So I would divide both sides by m delta T. M delta T. See that this cancels out. That means Q is equal to C over M times delta T. Now all we got to do is plug in because we already identified everything. Q is equal to C. Our C is 2,160 joules divided by the mass, which is 280 grams, and then that's times 36.2 degrees Celsius. I will say sometimes here, if you don't put parentheses, it messes up some of the students, right? If you plug it in directly, that's typically where the mistakes happen. So I have an old school calculator, so I'm not going to be able to do the parentheses just yet. So let me do the denominator first, 280 times 36.2. So on the bottom, I got 10136. Notice I'm not doing sig figs at the very end, right? That's just standard. 2160 is on top. 2160 joules over grams times Celsius, right? See, these two units kind of multiply together. And look, right, the units are going to become the units of specific heat, which means we're doing it the right way. Divided by 10136. And we get a really small number. Q is equal to 0.213, which should be correct because we know that conductive metals have really small specific heats. So in conclusion, know the equation. C is equal to Q m delta T. And then step 1, identify all of the variables. You do that by just looking at the units. Grams is mass, Celsius is temperature, joules is C, and the funky one, joules divided by grams Celsius, that's specific heat. Plug in, do some algebra, and you're done. I hope this was helpful. The best way you're going to learn is by going through the worksheet on your own. So try your best, go through the worksheet on your own. The answer key is posted, and then please reach out if you still need more help. Thank you very much for reaching out, and have a good day. Bye-bye.